So today is Contorted Compositions version 2. We're happy to have you here again, Amir, for a second webinar. And this webinar will be using Rhino Grasshopper as well as 3ds Max with tyFlow and then some Corona render. So really interesting mix of software in this webinar. Amir is a master's level architect and designer with great enthusiasm for the incorporation of technology into design practices. He's working as an architectural designer for more than 7 years, collaborating with architecture firms on multi-scale projects. In the recent few years, he has mainly focused on the investigation and research of organic shapes, responsive design, and computational workflows. Through these studies, he has explored and experienced various computer software and tools to develop unique design principles. So, welcome, Amir. Quickly before you get into it, just want to remind students that after the webinar, they'll be recording. It gets emailed to you automatically within 24 hours. So if you don't see it within 24 hours, make sure that you also check your spam. Sometimes it ends up there if you haven't whitelisted our email address. There is some files for you to download, which link is in the chat. And just a reminder that not everyone learns at the same pace. So if you feel like the webinar is too fast for you to keep up with, just feel free to just watch it now and go back to it in the recording at your own pace where you can pause as much as you like. But if you have questions, feel free to ask them, and please ask them with the Q&A button would be better. If you see where all your Zoom buttons are, there's one that says Q&A. This is just so that we don't lose it in the chat. But if you do want to chat in the chat box, please make sure that you switch it to say everyone, not just host and panelists. Otherwise, you're just writing to me. So make sure you switch that to everyone. So yeah, I'll give it over to you, Amir, and looking forward to today's webinar with you. You're muted. You're muted, Amir. Can you hear me, Amir? You're muted. Yeah, there you go.
Yeah. And my screen is clear?
Yeah, we see
yeah.
it.
Great. So thank you. And let me stop my sharing video to have a better connection. And I'm really happy to join you all today. And thank you, Michael, for introduction. It is my privilege and my pleasure to have this opportunity to share some of my workflows with you guys. And is there any problem?
No, it's good.
Great. Sure. So through this webinar, I'm going to show you some process and workflows mainly on the concept of minimal surfaces, but instead of using mathematical equations, I'm going to show you some process of using actually a mesh relaxation modifier and mesh subdivision modifier in different ways. So if you check this webinar, we are going to have this model as a first example, and then we are going to go to Grasshopper and having this model and another one actually to see how we can use almost the same principle in different softwares and add some features in any of these results. For the first part of our class, I'm going to get an introduction to 3ds Max, and if anyone is not familiar with 3ds Max, can learn how you can manipulate the software and get customized for your own use. Once you open the software, you have a scene like this. It has 4 different viewports and some modifiers here at the top and some actually panels here at the right side. So people often prefer to work only on one viewport. If you want to maximize this viewport, you can press Alt and W to make this viewport maximize. And if you want to change this perspective view to other views, you can easily come here and change your views, top, bottom, front, and other views. Also, you can use these hotkeys as it mentioned here. And another way to control your viewport is using this layout. For example, when I want to make renders, I would prefer to have two viewports at the same time. One of these viewports going to dedicated for my camera. For example, I have a box here and I'm going to get a render. Let me back it from default, from wireframe to default shading to see it better. And another view, I would put on a perspective and default shading again to, for example, this is my camera view, and I fix a camera here, press Ctrl and C to have a camera. And this is my camera, and this is my perspective view. So it is easy to have a fixed camera and then changes object or your scene features according to these camera positions. And another worth mentioning point is the factor of unit setup. In any 3D softwares, unit setup is important for us to see that in what actually unit setup we are going to work, in what unit we are going to work. For me, I always work with centimeters. And here in Customize, we have this unit setup actually box that you can change your system unit setup. I always put it on centimeters and also display unit scale on centimeters. You can change it as your own preference. And let's start with a quick example to see how we are going to use this mesh relaxation workflow. I would start with a simple plane to draw in an object in 3ds Max. Either you can use this panel, this standard primitive and object types. Here in geometry, you have different objects that you can draw in 3ds Max: standard primitives, extended primitives, and rest. Here in standard primitives, I have a plane. Another way to draw a object actually is call this object, just press X, and you can search any object or any modifier that you have in 3ds Max. For example, I want to draw a plane, press X and just type a plane. And yes, and then I can start to draw in this plane. Once I draw in an object here, I can access to its features here at modifier box or this modifier toolbar. For a plane, we have these parameters: a length and a weight, also a length segments and a weight segments. As you probably know, in any mesh objects, we have these segments that show us how these mesh polys arrayed or get or used. To see these segments in 3ds Max, we can press F4. F4 from is a hotkey that show us these edges. And changing these numbers of segments, we have a more dense plane without having any changes in this shape. I believe in all 3D softwares, we have such features. And the length and weight also is two parameters that introduce a plane. For example, if I draw a box, it is obvious that we have those modifiers that related to a box. For a box, we have length, weight, and height, because these are the features that introduce a box. And if I had a sphere, then a sphere introduced with a radius and also again some segments. So let's back to this plane and just change a bit its size. Something smaller. And the first modifier that is really useful in 3ds Max and in all process we use it is edit poly. This is the way that we have access to mesh sub-objects in 3ds Max using this edit poly. We have these subtools, vertices or vertex, edges, and polygons. Polygons means these part of a mesh object that create this mesh. And with edges, I have access to these mesh edges, obviously, and with vertices, I am access to these points. All modifiers that we have in 3ds Max are here in modifier list. So let's check it again together. We had so far this create objects, this create toolbar, and this modifier toolbar. In modifier toolbar, when I select an object, I have access to all modifier that possible for this object. And if I want to make those more useful modifiers out of this list, I can come here and use these show buttons, and I add some of those modifiers which are more common or more useful for me. And here in configure modifier sets, I can change these modifiers. Later at this webinar, we can see what those modifiers work for us and what is the purpose we can use these different modifiers. However, if you want to use any other modifiers here at this menu, you can just select your modifier and put it here to change these modifiers. And another worth mentioning point is that we need to use a plugin called tyFlow. Installing tyFlow is quite easy. I already sent this plugin link for you. After you open the link and download this plugin, you need to right-click on your software icon, come here in properties, open file location, and here we have a folder called plugins. Press P to find this plugins folder, and make sure to paste the tyFlow that dedicated for your 3ds Max version here. Once you install the software, you have all versions of tyFlow, and you need only to paste the appropriate version of tyFlow to your 3ds Max location. And yes, after having a tyFlow, you can see that you have this list of tyFlow modifiers in your modifier list. There are different tools that tyFlow brings to your 3ds Max. And I want to use actually tyRelax for the first example. And what is this relaxation works on a mesh? Actually, it implies forces that tend to make these edges length to 0. I mean, if I add more amount of this relaxation and increase this iteration, you can see it tends to make this plane disappear, because it starts to make these edges smaller and smaller. And in some iteration, it's going to remove my plane totally. To have a stretched surface or surface with 0 mean curvature, that's something like a minimal surface, though it is not a real minimal surface, because a real minimal surface comes from a mathematical equation. But I want to use this 0 mean curvature to make some geometries, right? I need to introduce some anchor points. If you are familiar with Grasshopper and Kangaroo plugin, you probably are familiar with how we can introduce anchor points. But let's see how we can do it in 3ds Max. I would back here in Edit Poly, and for example, select all of these corner vertices. After selecting these points, here in tyRelax, I have a ability that said use vertex selections. So I want to I want to apply these relaxations to all vertices except these 4 points. So back here and press Ctrl and I to invert your selection. I mean, at first, how to summon? Sure. Let's me to continue this one, and I will answer to you during our actually process. And I press Ctrl and I to change my selections. Right now, these corner points are deselected and other points are selected. So I can back here in tyRelax and use vertex selections. So adding more iterations means that these 4 corner points going to be fixed and other points going to change. After that, for having actually a smooth result, I can add a smooth, actually a turbo smooth, which is a subdivision way in 3ds Max. Press X and use a turbo smooth and add more iteration. We usually put this iteration maximum 3. It is works like cat mark in Grasshopper, and it is better to put between 1 and 3 and never go beyond this number because your computer would crash. So yes. And let's back here. This is the process that I use for relaxation this object. And one interesting item is that I can add another edit poly here just before my selection edit poly. Here I selected these points and I can add another edit poly here and change some of these vertices points. As long as I don't add any new edges, I can change these vertex positions without disturbing my process. I mean, for example, I select these 4 points and move them in z-axis like this. Let me put it here. I have something like this, for example, and then if I use this toggle, we can see the final result. You can see by changing these point positions, I still have a similar result in my final mesh. To get the writing window, you can say push it. What is it? I didn't get your mean. If I want to use any modifier, I can press X and call any modifier that I want to use. Press X and yes, use this one. And if you mean to maximize and minimize this view, I can use Alt plus W to change these maximize and minimize views. Sure. So back here, and I'm able to play in with these point positions, right? Something like this, and use this toggle to see the final result. And because these points are not anchors, even changing these positions does not make any big changes in final result. So I need to back here, and among these points, I want to deselect these all points, these all top points. Press Alt key and deselect these 4 points. So let's look at the result. These are my new anchors, and you can see how these shapes get changed according to these new positions. And for having this process more clear, I can rename these edit polys. For the first edit poly, I can say vertices position. And for the second edit poly, I can say vertices selection. Yes. So as long as we have similar numbers of segments, I mean, without changing this number of segments, it is easy to design here in vertices positions and then see the final result. Just back here and make any changes that you like. For example, this one, and then use this toggle to see final result of the process. Yes. And let's develop our base object by using another modifier. We are going to use another modifier called symmetry to develop this object. Just add another edit poly here, or I can see what if I add more iterations here. Back here in tyRelax. Yes. Just accidentally I deselect those vertices and I need to select these R again. Deselect these anchor points, and I want to see my tyRelax in other points. So these yellow points, these red points are the points that tyRelax is going to apply to them. And these blue ones are my anchors. And let's look at the result. Oh, I move, as you can see, changing this. Maybe I can more iterations. And you can see by adding more iteration, I am able to modify this object. Or changing this amount. And back here in vertices positions, for example, select this vertex, move it. And here in vertices selection, deselect this one as well to see what if, yes. Maybe I would like to have something like this also here. A new anchor point here I have added. Some different results. And for the next stage, I want to add another component, which is symmetry. But before adding this symmetry, I add another edit poly here. Sometimes edit poly without having any changes make us to actually rebuild our mesh. I add another edit poly here without having any changes in our object. Just make sure to all my polygons are in a right way and there is not any problem. Then I add this symmetry. And symmetry basically help us to have a mirror and cut object of my main object. I mean, here symmetry has a mirror plane, and it helps us to have a copy of my object. And I would like to use this Y direction. Maybe something like this. And back here in vertices positions, I would like to move this point with this. And let's move these vertices as well, like this. And I want to select these vertices. Just playing with these vertices positions to have a better curvature. Yes. And let's check it in extraction. Which one is better? Yes, I believe this one was better. And after that, I can add another symmetry if I like to have, for example, two series of these objects. Just move these symmetry positions and having something like this. Yes. And too much. Yes. Yes, sure. You should, after installation the tyFlow, you should add this here in the plugins. Just open your 3ds Max root folder. Here I have 3D Max 2020, and here we have a plugins folder. At this folder, I can add this tyFlow DL file. Once you download a tyFlow, you have a list of this plugin according your actually 3ds Max version. You should paste the tyFlow file here in plugins, and make sure close your 3ds Max once you are install this plugin. And for the next part, I want to add a shell to this scheme. So using this shell component, press X and add a shell. And then I will have a result like this. And press M to open your material editor. I want to use this Corona actually tab. And here in Corona, I have a Corona legacy material. Materials. Yes. And apply to this and change its color. That's a way I can design an object by using this mesh relaxation. And it was a quick example to see how this actually modifier works. And even if I want, I can add another relaxation after this process. For example, here, add another tie relax to somehow modify these changes here at the middle. And just I want to say relax vertices on closed edges, which means all of these borders will remain fixed, and I just change these middle parts, these closed edges. Let's look at the final result. Yes, I can add another turbo smooth here. To have a better visualization. And as you can see, I changed this turbo smooth iteration to 1, and then add another tie relax, and again add another turbo smooth with iterations 2, which means all of these 2 turbo smooth together has 3 iterations to control the numbers of my polygons. And let's make another quick example to have a better control on how these actually relaxation works. I can also offset these borders if I like to have maybe a better result. Yes. And save this file and make another example. For the next example, I'm going to show you how we can draw something like this object. Actually, it is another relaxation model, and probably you can understand that they are my fixed points, and these tie relaxation apply here at the middle parts. Let's make it together to see how we can have this model in 3ds Max. Delete this one. Let's start with having a box. Press X, type box. And I would like to have 80 length and 74 weight and 400 for its height. Then I should see how many of these opening parts I want. By changing these height segments, I can have a more division on my object. For example, I want to have 8 segments to have something like this. And then add edit poly. And let's see how we can control these objects. First, I want to extrude these parts because we have, as you can see, these extrusion. And similar here. Oops. And maybe for this part, I want to select these ones. Yeah. Select some of these polygons and then use extrude. 3ds Max is able to extrude polygons locally, which means you can select different polygons in different direction, and by using extrude, any of these polygons extrude in their own direction. Like other 3ds softwares, maybe only Rhino doesn't have this ability. I mean, in Rhino, you are not able to select different polygons in different direction, at least in my knowledge, and do extrude together at the same time. And having something like this, maybe. Then delete these borders, delete these polygons to have a border edges, and let's make it. So Also here for the top, I can use extrude. And also for bottom part. And 3ds Max also has own relaxation. I mean, apart from tyRelax that we already seen, we can use a 3ds Max own relaxation. Here we have this relax modifier, and it is quite similar, having iteration and a relax value. But and let me use a turbo smooth X at turbo smooth. If you are if you have a knowledge of Maya, you're probably annoying to see these edges. In Maya, you have another sort of visualization that you can see smooth shapes without having these edges. Also in Rhino sub-D, you can have smooth shapes without having these edge divisions. Sometimes it is annoying to have this much of polygons, at least in your view. So I can use another modifier instead of using turbo smooth that has a similar actually use, but it doesn't make any subdivision in display mode. Use open subdiv and put iteration on 3. That's how you probably are more familiar to see objects. I mean, without having those mesh divisions, and see only the smooth result. You also can use open subdiv or turbo smooth. Both works similar, just the visualization are different. So back here in edit poly, here in 3ds Max Relax, it is as default, it keep boundary points fixed, which means we have these vertices as our anchors, and the relaxation only works here at the middle of my object. But because we have less objects, the tension is really low. What I can do is add some edges here at the middle of these divisions. I mean, select these edges and yes. And add more vertices, more edges. Having more edges means that we have more space to add those tension, those relaxed tension or relaxed force. So use a connect to add some connections here. And also I can use scale to scale these loop edges locally to have something like this. Also, I can do it for here. And let's employ this relaxation again. And you can see that the result is almost similar to my example, to my model. And after that, I want to have these offset borders. So I can back here and select these borders, press select one of these borders, or select Control and A to select all of these borders. Select all of these borders, and then I can press Shift and make a duplicate edges of this loop selection. something like this. And because a relaxation also works here at these edges, I would be able to make another edit poly after relaxation and select these borders and again make a duplicate. And right now, this scale works locally. You can see that any of these borders has their actually the center points of their own for this scale process. But if I change this pivot point center to use a middle for all of them, then it uses the middle of object for all these scales. If, for example, you want to do something like this, you can use a similar middle point for all of these borders. Or back here and use this mode to change any of them equally. Yeah. Anytime. And after that, I want to add a shell modifier. Press X and add a shell. Yeah. And change its color to see it better. So we will have something like this. And I can use this clay display mode to have my result, to see my result a bit better. Again, like previous example, we can back here and playing with these edges positions to see different results. For example, if I want to see more attentions, I can add more actually loop edges. For adding these loop edges in the previous example, I select all of these edges, these loop edges, and then use this connect, right, to make a loop edge at the middle of these segments. But there is another way. As long as this edit poly are selected, I can come here in modeling. I have this Swift loop that help me to make those loop edges much faster. If I stand on these actually horizontal edges, I can draw a vertical loop. By loop, I mean we have edges all around these surfaces. And if I stand here on these vertical edges, I can draw a horizontal loop. Having more loop means we have a more modify in our object. Just see here how it is. It has more tension rather than others because I add some edges here. I want to just show you how we can modify them. For example, if I add 2 more edges here, you can see that we have more tension here and it starts to a bit get problem. Maybe I can, yes. Maybe it is show us better. The more edges you have, the more tension and the more relaxation you will see at your final result. And it is really up to you that how many edges you like to add in any of these objects. And also I can change these vertices position, for example, like this. and have some different results. Yes, I just wanted to show you this example to again have a better understanding of relaxation and how it works. And let's see what if I use tyRelax instead of 3ds Max Relax. X and type tyRelax. And again, I want to use relax only on closed edges. Relax vertices on closed edges. And like this. Maybe it is a bit, I'm not sure even there are 99 and 1, and let's put it 99 and 1. Yes, this is the tyRelax, and this is 3ds Max Relax. Almost similar in this example, but tyRelax, we have this option that use vertex selection in some previous example, and the next example, we've seen how this option help us to modify our anchors selections. But in 3ds Max Nature Relax, we can't select anchors, and only boundary points going to consider as our anchors. Okay, let's save this one. And for next example, as we get familiar with Edit Poly and how Mesh Relax and subdivision works, we are going to see this one, which is a bit more complex to modeling, but similar process. Let's see how we can have this object or this model. For this one, I start with a box object. Yes. X, draw a box. And change to default and press material editor, give it a color and change these edges color to blue to see better. Yes. Here in modifier, I can change this object size. And the number of segments. I have something like this, maybe. First, I want to twist this box as you see at this object. Let me show you hold the process at first. I believe it helps us to have a better understanding of whole the story. Just before drawing this together, I want to show you the object. Oh. Let's look at this and then drawing together. If I back here and disable this toggle, you can see we start with a box and then twist it to have this curvature. And after that, I remove this connection between these two surfaces. I mean, here we have a connection because it is a box, and I delete these weights, actually polygons, to have two separate surfaces, and add another surface actually to have three surfaces that twisted together. Then make a few changes in this actually positions in this deformation. I deformed this object and then use a turbo smooth to make it smoother and use a symmetry to make this whole low poly object. Let's do this part together and then jump to next part. I show you right now. I just wanted to give you a total understanding of whole the story to see it again together. And yes, so let's back and start with a box object. Come here in modifier and example 2, 12. Oh, sorry. Yes. And change its color. Then press X, add this twist option. So basically twist another modifier of 3ds Max that, like any other 3D softwares, we have this twist ability that we can make a rotation on the object. And it is really important to check in what axis we want to use this twist. Here in this example, I'm going to use this twist in X direction and make it more. What I want to have and what is important for me in this example is having these end edges aligned with the ground. I mean, something like this, where I can have align edges with my ground. And I don't want to apply this twist in all this box. I want to have twist here only at the middle. So I can use these limits and, for example, here and here. It has an upper limit and a lower limit because hopefully it is obvious. We have this orange color borders that shows the limitation of our twist or the area that our twist works. Here is the upper limit and here is the lower limit. And as I said to you, I want to have these edges align with my ground. So maybe I can change this twist. This one is good, but this one needs to have more rotation. Oops. So change these positions. Yeah. Having something for like this. And also I can select this gizmo. We called this one a gizmo. And use a scale to change this gizmo area. Actually, we have two ways to manipulate this gizmo, either using these limits or either using scales. I just mentioned one important point that I forget. For moving an object, let me turn off this gizmo. For moving an object, I can use a W to run this move icon. I mean, move an object. For rotation, this icon, I can use E hotkey. And for scale, I can use R. It is like other 3D softwares. I mean, at least in Maya and ZBrush, we have similar functions. W works for move, E works for rotate, and R works for scale. Okay, let me hide this object, select this object, and use this hide selection. And move it a bit. If this ground annoy you, you can press G to disappear this ground. And Let's add another edit poly. I want to delete these middle polygons to have two separate surfaces. And don't forget, if I back here and without changing this segment's number we call mesh topology. Without changing this mesh topology, I'm still able to change these parameters. Yes. And I would like to select one of these two surfaces, for example, this surface, and yes, here in element, I can select these separate surfaces. With polygons, I can select these polys, and with element, I can select whole separate mesh, actually element. And for a second, I detach this object to have two separate meshes. And for this one, I want to use a shell. And offset this one. Another surface. And add another edit poly and select these borders and delete them. So right now I have three twisted surfaces that are complex, that are together, and one of them are separate. To have only one mesh out of all of these faces, I can use this attach and make sure, or select this one and use this attach and make sure to attach these all three together. And let's back and see let me close this, our sources. I want to have something like this. So in this stage, I am going to add a symmetry to see how it works. And in Y direction. And also I would like to have a turbo smooth. So you can see some of these parts are totally separate from the object. So I need to make some changes here just before doing this symmetry. I want to use another modifier called freeform deformation, or FFD. I believe in some other softwares you have something similar, this FFD. For example, in Rhino, we called it cage. Using this cage, in Rhino, you are able to have these control points, and in ZBrush, we have also these FFD with similar name, freeform deformation. And I want to move this part like this to have more control. And for these borders, I want to having something like this. And also here. And change these mirror positions again. And I want to have a connection again here. So maybe I need to select these control points and make them closer. In this way, I'm sure that have connections between my mesh objects by changing these point positions. And it is still separate, so I should see how I can make this one closer. And back here in Edit Poly, I can change these vertices positions manually. Because in my example, I want to have a chamfered edges. You see, these edges are chamfered. And somehow I need to control these borders. Also for this one. Oops. Make these vertices closer together to have a smooth corner. Also, I can change a bit this one and this one. Yeah. After that, I'm able to use a scale for the whole object. Press R to scale. And then I would like to make some connection between these separate surfaces. I mean, select this surface, for example, and make a connection with this one. It is right now a low poly object, and we have a less polygons. If I want to have more division that give me more spaces to playing around, I can use a turbo smooth here, X turbo smooth, with only one iteration, and then use this edit poly after my turbo smooth, so I have more polygon to selection. Before having this turbo smooth, I had less polygons, and it was a bit harder to make more connections between these three surfaces. But after having this turbo smooth, it means that we have more polygons to playing around. So add this turbo smooth and select, for example, these two polygons, and select two polygons from here. Let's see if we can make a connection between them. Here we have a problem. You can see that this bridge between these two polygons faced some problems because it is meshes has a face, I mean back face and front face. And if you are going to make a connection between a back face and front face, you will have such inner intersections between these polys. So to solve the problem, I can select these top polygons, for example, and use flip to flip this mesh. And then you can see here is a darker red, and here is brighter red. And if I select this one, also you can see here is darker red and here is brighter red. To make a good connection between these two faces, I wanted to make sure that both front faces or both back faces are faced together. So back here and select these two polygons, and for example, these two polygons to make a connection by using this bridge. Right now it is much better because all of these are front each other. So let's make more connections. And back here and look at our reference, you can see that, oops, we have such connections, which is interesting, between different parts of our object. These connections, I mean. The more time we spend to make these connections, we have a more integrated object. I mean, when an observer look at this project, it is harder to can understand there were separate surfaces as we have more connections, and it seems as if we design all of this object together. So it is important to have enough connections between different parts. And do not forget that we have a symmetry object. Actually, it means any of these connections we made, it actually has a two side. I mean, we have still some problem here. Yes, it is better. Like here, select this edge. And because we have a symmetry, I select one polygon here, and at the mirror, polygons are going to select automatically here. Select these two together and select these two and make a bridge. Then we have something like this. And select these two and these two, make a bridge. We have something like this. Let's continue to make connections. And I think we need to just maybe change these edges. Yes. There are some gaps that I want to fill these gaps. I can move these edges to make sure that they are together. Also here we have some gaps. Yes. And oh, yes, I want to have a bridge like this. And once I'm happy with these connections, I can select, for example, this front. For example, I can select this this surface again by using polygons and make sure to check this by angle to select any of these surface again after these connections. I mean, if I want to use element again, because those connections, I'm not able to select these surfaces separately. But back here in polygon, and just make sure to use by angle to make limitations of a polygon's angle for a selection. Then I select, for example, this surface, and I can again select this. And once this surface is selected, I use FFT. FFT only apply to these red surfaces. I mean, only apply to these red objects. And look at here, I change these point positions, and only those part of object that are related to these red polygons are going to change according to these modifiers or to these FFT modifier. And it is another way that I can having more control on my object to make it a bit interesting, maybe. And also we have other ways of FFT. If you want, for example, use XFFD from freeform deformation for a point coordinate for control points, which give us more points to playing around. And instead of using this FFT3, I use this FFT4. And you can see that I am able to make a new changes. Just after I'm happy with this result, I can add another edit poly to make this object integrate again. And for example, I want to select this middle surface, use by angle and select this one. So I can select this one again separately and use another FFT. Let's see if I can make any change also here. Use these points. And for example, I want to have more spaces here. Once I'm happy with the result, maybe we can do more changes, but because we are going to cover some other topics, I want to do this process I want to stop this process at this stage and go for the next modifier. After having this object, I can come here and use tyRelax. I want to say relax on closed edges to use all of these border edges as anchor, and see, you can see that all these other edges start to have relaxation. It helps me to have a smoother object. And let's put it just after Turbo Smooth to have more edges to apply this relax. and X, another turbo smooth. Oops. Just save this file. Yes. And if I have any problem here, for example, I can back and change it. Yes. And yes, just add another smooth. Have a better result. After that, back here and look at that we have some offset on these edges. Just I need to use another edit poly and select these borders. You can see that I select these red borders, press R for scale, and press Shift and move to have a offset border. Also for this one, select these borders, press Shift and R to offset the border. I would like to do it for most of these edges. Maybe it is more interesting to have these offsets. And even if I want, I can make it more complex. Yes. See how these, how you can see how these borders looks interesting. Just select the borders and shift and move to make a something which is interesting. Yeah. And the next stage, can you make the border offset? Can you set type a specific distance? Well, let's, I'm not sure, let's check it together. For example, I select this border and I want to use offset instead of using, yes, just, actually, I believe I can say the scale factor, which comes from 100%. If I use, for example, 120%, then it implies with a scale, but it is not like centimeters or a unit, but it is according the object scale, and it doesn't make sense in this way. Let's see if we have another option. What if I use this extrude? Maybe this extrude makes something similar for us. I'm not sure, but let's see. This is how extrude works, and this is how scale works. I mean, the direction is a bit different. When you use this scale, the direction of these edges are different by when you use this extrude. If this extrude has another option. Maybe if you playing with this extrude ability, you will have just you will have access to what you are going to what you want. Yes, the best option that I can suggest you is using extrude instead of scale. And let's look at the result. So for the next part, I want to select some of these strips. You see these colors strips, and instead of giving a color, this time I want to do something else. For example, I select this polygon and then press a Ctrl and Shift to loop selection. Or a better way is using edges. Come here and select this edge and this edge, for example, this two edge, and then use this. We have two options, ring selection and a loop selection. And it is not really obvious which direction is a loop and which direction is a ring. Sometimes they change their definitions. Sometimes when you use the ring, it select direction in this way. And sometimes when you use a loop, it select direction in this way. So it is better to check both of these loop and ring in any of these strips selections. After selecting these edges, I can press Ctrl and select this polygon to select all these strip edges. Then I can detach, use this detach to separate these selections from my objects. And you can see that I have this open hole because I detach this strip. Either I can change its color, change its material, or I can add another modifier for this one. Press X and use a lattice modifier. Change this lattice to only structures and smaller structure. Maybe you would like to have something like this on your object, or you can use a turbo smooth to make it smoother, and also a turbo smooth for this one before adding the lattice. So you will have a more dense lattice structure. And in case that you like to change your lattice topology, add another edit poly, and here in polygonal modeling, we have generate topology, and I can change this topology. Here I have a topology edge direction to have a different, you can see mesh topology. Here these are quad meshes, and here these actually n-gon meshes. Maybe it is a good idea to add some details like this to our object. So let's do it again together. I select, for example, this edge and this edge, and some here, this edge and this edge. And for example, these two edges. And make sure select ring or loop. We can check both of them to see which one is our purpose. And then press Ctrl and select these polygons to turn our edge selections to polygon selection. And then I have these selected edges. Here I can deselect from this one. and detach. So I can back here to save my time, copy all of this process and select this one and paste here to have a similar result. And finally, when I'm happy with this object, even after that, I can use another tyRelax. And this time relax all vertices to have some control also in these edges. Oh, if I do this so, then these lattice parts are going to have a problem. So maybe it is better if we use this tyRelax before adding these details. I mean, that was definitely more interesting, but we have to use a tyRelax before separating these parts. So let's add a shell to our surface. Make it like 1 or 0.5. Yes. And another interesting fact is that I can back this process. As you have seen, I have some problems to add a tyRelax because of this lattice. So I can turn off these lattice edit poly, and it's going to remove that previous process. So I can add tyRelax again without having any problem. I want to just show you how we can solve this problem. So, and once we have a such object, it is also possible to add another symmetry, for example, to see some other possibilities of my object. I mean, make a copy and remove this symmetry from here. This one was the thing I designed, and this is another possibility of my design object. I mean, just adding another symmetry. You can see how this shape changed with this mirror at the middle, or even I can move this symmetry plane. Yes. Select this mirror plane, and for example, rotate this one. It is going to be to totally a new object, a new concept. And if I would like, I can add another symmetry here to have, for example, something like this to see the possibilities of changes in this object. And select this new symmetry mirror and see how I can change this one. Or flip, using flip to flip my mirror plane and change it according to this flip object. Yes. And again, add another edit poly and another symmetry to expand the design. Yeah, another footwear. Yes, you can consider it as a footwear, but I consider it as a building actually in my eyes. And yeah, for the next part of our class, actually, I'm going to use this mesh relaxation process in Grasshopper. Let's do a quick example, and then we will have a 10 or 15 minutes break, but it is important to have some parts again in this stage of our course, of our webinar. I want to draw a plane here in Rhino. And let's see how we can have those relaxation here in Rhino. For those of you who are not familiar with Grasshopper, I can make a mesh of this surface object using mesh surface, and quite easy process. Just only, I consider that you're familiar with the whole Grasshopper story, and I want to just show you the process. But if you have any problem with any of these components, please let me know. Here in Kangaroo 2, we have this component edge length to have something similar mesh relaxation, and I can use these anchors for anchor points to extract these anchors, these corner points, like our first example in 3ds Max. I want to use these points as an anchor. I can use naked vertices component to extract all these points, and I want to have these corner points. So use a point list and look at these point numbers. What is the problem? Yes, it's too small. Let me make it smaller. Yes. Yeah. These are my points number, and I want to select these 4 corners. So 0, 5, and 19, and 14. I want to have these points. Make a panel 0, 5, 14, and 19. Multiple data. And use a select item. These are my list of points, and these items are my anchors. Also here, it asks me for a mesh object. This is my mesh object. And like what we made in 3ds Max, we need to make these edges tend to be 0. So here in this component, I want to put this length factor on 0. But let's put something between 0 and 0.25. Oops. 0 and 0.25 for this length factor. And to see the process, I need a Kangaroo solver. Use a Kangaroo and use this solver. And I need another component, which is a show, to see the final mesh. And use a merge. I want to use all of these goals for my goal object, so I can use a merge to make all of them in one output list. And I need a toggle, Boolean toggle, to run this solver, and a button to reset the solver. Yes. And the output here, is actually one mesh, and some other goals I want to see only these mesh, so I can use a tree, explode a tree, and this is my mesh. You can press Ctrl and Q to preview off these components, and reset this one and run. You can see it works similar to what we had in 3ds Max in previous examples. And using Weaverbird plugin, we have this Weaverbird's cat marker to make subdivision, like turbo smooth subdivision in 3ds Max that we have seen. I'm able to make it smoother. This is the whole process of relaxation in Kangaroo and Grasshopper, but I want to use this notion, this idea for making this object. Yes, we are going to make this object by using this notion. So do you have any question, or do you want to have a break, or you prefer to continue our process? Please let me know what you think. Do you need a break? Sure. So, yeah, sure. So let's have a break for 10 minutes, and we will back in 10 minutes. Yes. Okay, let's continue if yeah. So this is the whole story of how we can use relaxation in Grasshopper. I just disable this one and move it here. For this example, this model that we are going to make, I have a reference render that used for promote our webinar. And because I wanted to have a result more or less like this one, I already use these curves to see the process. But initially you can use any curves that you like. Add these curves to my Grasshopper canvas. Sorry, add these two curves to my Grasshopper canvas. And you can see that we have different steps. Actually, any of these steps are the positions of my anchor points, and the load or the relaxation apply to these other surfaces, these other mesh parts. So for having these different steps, I would, to see those steps, I want to use a twin curves component. Though we are not really using these twin curves, but only to have a better understanding of the process of, I want to use these twin curves and use a list item. We have two curves, the first and the second. And I have like 8 steps. So put these factors to 8 different steps, use a range because this factor always works between 0 and 1. The domains of my range is as default between 0 and 1. So I need only to put this number on 8 to have these steps. And use a loft. Here, there is no difference. Either I use a loft directly or use these twin curves. I only add these twin curves to see these positions. And I want to make a mesh of these surface object, but I want to have separate meshes on any of these steps. So I would use isotrim component to divide my surface to some smaller surfaces and make separate meshes of any of those smaller surfaces. We have a divide domain 2 component, and this is my object. And let's see how it divide my object. I want to have equal U, and for V direction, I want to have 2 parts. So if I use a list item, you can see that list item. We have like 16 surfaces. Any of these parts are a different surface. Yes. And I would use mesh surface. To make separate meshes of any of these surfaces. Let's change these segments divisions like 12. And because they are separated mesh, if I use a naked vertices, naked vertices, you can see that we have these naked points, which are going to be our anchor points. And we have also some closed points, which we are going to put on forces on these points. Sorry. And let's do a similar process of this example one more time. I need anchor points for these naked points. I can flatten this one. And I want to use edge length for this mesh object. Zero to 0.25, for example. And we need a show component to see the result. But I can use a join mesh because there are 16 different meshes, but here in show, finally, I want to have only one mesh object. So I can use this join mesh and then use here. But we are going to use another component, which is a load that help us to imply forces on these closed points. Here in Kangaroo, at the tab of a goals point, we have a load that can apply to points actually, and I want to use this load for these closed points. For my load, I need a vector that show us in what direction these points going to imply a force, and how I can extract a vector for them. Let's look at this data structure. Actually, let's simplify this one. We have 16 branches, and any of these branches has 121 points or members or items. So if I have 16 vectors, I can use one vector for any of these branches. I have actually 16 faces, and I want to have one vector for any of these faces. Let's preview this one off, like it here. At the middle of any of these surfaces, I want to have a normal vector to apply to these loads for my forces. So I can use evaluate surface. This is my surface object, and make sure to reparameterize this surface. We can use MD slider to make a point and any of these surfaces. You can see that at the middle of any of my surfaces, I have one point, and I can change these positions. If you are not familiar with this rationale, once you reparameterize a surface, it's going to make it domain between 0 and 1. So the length and the height of any of these surfaces are going to be in a domain between 0 and 1. So here at the middle, we have like 0.5 and 0.5. Because I don't want to playing around with these point positions, instead of using MD slider, which is a bit big component, I can use a simple panel and just write 0.5 and 0.5. Give it here. It has a similar result, and we have these middle points. So I'm able to use these normal vectors for my loads, but let's look at our vector. I can come here in display and use vector display to see this forces direction. This direction actually is inside the object. Probably my surface are flip. Let me bake this one to see it together. Yes, I already put my Rhino customizer to a backface color in blue, and this blue color means that my all my faces are flip. Just I wanted to make sure why the direction is like this. Actually, for my purpose, I want to has this stretch like inner side, so it is good for me that the direction of this vector is like this. But if I wanted to change it, either I was able to flip my surface or reverse my vector direction. Flip surface. That changed the directions of my vector, or I was able to use reverse vector. Oh, sorry. Yes. However, I don't want to use them. And for having more control on this vector, I can use amplitude to multiple this vector in a number. I mean, this normal position show us the direction of my forces, but for having more control in these forces, I can use an amplitude between, for example, 0.0 to 1.5, and use it here. Also, we have a weight, another way to control the force of our load. I would put it like 0.12. And remember that we have 16 branches and we have 16 vectors. So I need to graph these vectors because I want to have one vector for any of these branches. I mean, any of these branches related to one of these surfaces. So any of these vectors also should be related to any of these branches. And and after having these forces, I can use this Kangaroo solver, merge all of these together. I can flatten this one. Put a button for reset and a toggle for this. For run the solver, I can use a toggle, and for reset the solver, I can use a button, and these are my goals. Preview all of these ones off. And explode tree to extract the mesh object. Yes. To see the result better, I can use a custom preview and give it a color. Swatch color. Yes. If I add more weight and reset it, it has a better result. Is similar to what we had actually here. And and I can use Weaverbird cat marker to make this mesh smoother. Yes. And after that, we need to have these frames, these object frames, right? For this part, I want to do something manually. I mean, without using Grasshopper, I just bake this object for a second and select all these border edges. Press Ctrl and Shift to select these edges, these loop edges actually. See, there is, yes. Oops, I should hide this here. Yes. I have to do this process again because I lost my selection. And then duplicate these edges by using this Rhino component duplicate edge. Then hide this object. And select these duplicate edges. They are not joined curves and we need to join them together. So use a joint and add them to a Grasshopper. Set multiple curves. So we have 8 curves and I want to use these curves for these steps frames. So it is easy to use perpendicular frames, give them here, add more numbers of steps. Yes. And make a rectangle on any of these frames. For X and Y actually amount, we need to have a domain. So use construct domain between, let's 1.1 and negative 1.1. Yes, you can see we have some rectangles here, and I can use a loft on these connections. And yes, we have to make sure to come here in loft options and close this loft. Yes. What if I make these frames a bit bigger? Like 1.6. And here at the bottom part, I need to have overhanging. If you look at it better, we have some offset. And to make these offsets, what I can do is actually select this mesh. Mesh edges. Mesh. It's me. What? Yes, this one. Mesh edges. And extract these border edges. Join curves. And I want to select this bottom curve. So use a list item. Not this one, but the second one, this one, yes. And I only need to add this one to this list. So use insert item. This is my item. In this, it should be 0, for example. This is my list. Yes, but I wanted to have an offset. So use a component offset lose. Because these curves has some curvature, if I use a simple offset, sometimes it has a problem with a simple offset, curve offset. Here it works, but when these curves are not planar or planar, sometimes we have problems to use offset curve, and we can use offset lose in these situations. I would prefer to use this offset lose and give it a overhanging amount. Maybe we need 125. Yes. And use this offset. Use this item here. And this should be here. Yeah. And I need to make a connection between this curve and this curve to fill this gap. So use another loft between this curve and this curve. Oh, actually, there are two curves, and I need to use this one. This curve and this curve. Yeah, to fill this gap. And let's back and look at our reference. Next, I need to have these interior structures, interior frames. There are different ways to make these a structure. I want to use a 3ds Max here because it is much faster, and I want to show you how we can play in with topology between Grasshopper and 3ds Max. Just bake this object to see on the Rhino. And this is my object in Rhino. Select this mesh object and export selected. I want to export as a FBX object. Give it a specific name, Rhino to Max. And back here in 3ds, let me open a new scene. And import the object. Just paste this address here and use this open and select this object. Yes. I have the object here and it is black because actually it is flip. If I want to, can use a normal component to make it like this. And let's look at this mesh topology. We have too much edges, and for this structure, I want to have less dense of edges. So first of all, I can use convert to editable poly to remove all previous modifiers and use this polygonal modeling, generate topology to change this topology. And it is too dense. I can select one of these edges and double click to select loop edges. And you can see that it selects almost half of these edges. Then I can press Ctrl and backspace to remove these selected edges. Yes, right now we have less edges with similar directions as we made here in procedural topology. And there is another point, actually. This structure, this pattern should be in the interior side, in the inner side of this surface. So if I use this mesh object, then it is the structure going to be outside of my surface, but somehow I should push it interior, push it inside. Yes, so I can use a shell modifier and use inner amount. For example, 4 centimeters. And then here I can select inner faces to select these interior inner parts and use another edit poly, use polygons and press Ctrl and I to select invert and delete these outer spaces, outer surfaces. We have some problems here. I believe I should make it like 2 or 1.5 to solve the problem. Once I have these edges, I can use this edge actually component and select all of them. Just I don't want to select these borders, so back here in border and press Alt key and deselect these border edges, because in my concept these are not actually at the end. I wanted to only have these surfaces on these edges on the surface, not this border one. And use a component, create shape. It works like the component we use in Rhino, duplicate edge, make a curves of our edge selections. Use a create shape. And there is a point actually, if I use editable poly instead of edit poly, these are two ways of access to similar modifiers. If we use editable poly, all these previous modifier stacks going to vanish, And yeah, I want to use this one. And here I have more option. Even I can make smooth shapes of my edge selections that you can see it. Shapes going to be a bit different, these blue ones. This is also interesting pattern, but I want to be loyal to my references, so I will use this linear one. And these curves are exactly on my edges. Finally, I can select these curves and export it to Rhino. Copy this address back here. And I want to use a DWG max to Rhino. It takes a few minutes. Let's back here. Before adding those objects, it is a good idea if we delete this one and select all these curves, put it in another layer, change object layer, and hide these objects. So file, import, and import these data values object. And okay. Yes, this is my frames, and I can actually, this is my structure, and I can change object layer, call it structure. Yes. And save this Grasshopper file. And save this Rhino file. I want to add these curves to my Grasshopper canvas also. Set multiple curves. And then here in sub-D, we have a multi-pipe. I can use this multi-pipe to make a structure. And you can see all of those curves are inner of my face because I use those shell rational to make these curves in this inner space. And pipe radius should be smaller. As default, it is 0.5, but I want to have like 0.25 because I don't want to see them come out of my actual surface. It is a bit time-taking component. And let me know if you have any questions so far, because it probably takes like a minute or 2 minutes. Yes, it is of course possible to access to this process in Grasshopper use actually mesh edges, but I wanted to change the mesh topology. I mean, not only change their direction, but having less dense actually mesh edges. So I had to use 3ds Max, but if we have a time, I would show you how we can do this one in Grasshopper as well. Just make sure to work this structure. I will show you how we can have almost a similar process in Grasshopper. Actually, it is not good idea to have a constant update between them because they do not have a live connections. And however, for a 3ds Max, FBX is a good idea, and for Rhino or WEBPAGE is a good idea, especially if you want to do visualization in 3ds Max and modeling in Rhino. It is a really good idea if you use FBX for sending object from Rhino to 3ds Max. Yes, it seems that it doesn't work. Yeah, it works. It takes like 3 minutes, which was not really a parametric or procedural way, but I wanted just to show you the structure. Yeah, having such a structure. And I can bake this one. And again, and disable because it is really time taking. And the interesting of this sub-D structure is the fact that it makes something which is integrate. All of these edges are connected together, and it really worth to spending this time to calculate this structure. You can see all of these structures part are connected together without having any problem. And let's back and see, are we going to model some more minimal surfaces in Rhino and GH? No, not really, but for the next example, I'm going to show you this one that I use for a promote the workshop. Actually, this one also made in a Grasshopper, but it's not actually the process of minimal surfaces, but using volumetric modeling and I would say a natural, some nature components of Grasshopper. And after that, also after this finish this model, we are going to see how we can make such textures on this. I mean, how we can change these texture positions to have something like this, or having these other textures on my mesh object. Yes, both is good. I believe multi-pipe is a newer one, and probably it's work better, but you can check both of them and see which one is better. For those of you who are not familiar with Fatten, it is a similar component here in Grasshopper that we can use. I believe this one has a similar process. You need to give it a skeleton and a radiuses to make such structures. However, let's back to our example. And I am going to use these curves for Yes, for this part, I only need to project this curve and use area to select the middle point, and then use a scale. This is the geometry. This is the center. 0.85, for example. And make another loft between this curve and this curve. And let's make it a bit smoother. What I can do is actually use another twin curves. This is curve B, this is curve A. Yes. And I want to offset this curve a bit. Offset. Lose. For example, 1.2. Yes. And use a merge between this one and this one and this. So I can use surface a bit like this. Yes. And use a architect view and use a custom preview for this one. And this. So I need to have some frames also, some structures also here. And it is BREP object. I can use the construct BREP to make a series of faces of this BREP object and extract these curves. So I want to have these frames, these bottom parts frames. How I can select them? Right now they are closed curves, which means any of these faces, if I use a list item, all these edges, these curves make only one closed curve. I need to explode these curves to a series of segments. Then I'm able to select any of these surface individually. So let's put explode here. And there is a problem. I'm not able to use a list item to select all these horizontal edges because the number of these curves in faces are not equal. Let me show you my point. If I make a point on any of these curves, sorry, any of these segments, and then use a point list. I want to select these middle curves. What you can see here is 0, and most of them are 3, but this one is 0. And it makes it a bit difficult to select them. One thing that I can do is flatten all of them and use remove duplicate lines. No, it doesn't work here. So let's see what I can do is I have these faces and extract these curves, or directly I can extract these edges maybe and use remove duplicate lines. No, it doesn't work. So let's use this one. Use a explode. Yes, edge length is good idea. Thank you. I can use edge length, explode these curves, extract these edge length from these segments, and let's use an average. Average helps us to have the average number, the average size of this edge length. It is obvious that these bottom and top edges are too smaller and these middle edges are too longer. So if I use a larger component and I would say compare these lengths with the average length, I can use flatten, but without flatten, use any of these faces actually separately. I mean, any of these faces has 4 segments and it start to equal these process for any of these 4 segments separately. Let me put this one here to see how it works. And then I can use a call pattern. Put a pattern here and put this list here. And I can select all these actually middle edges. You will have a special award for present. And after that, you can, if I use this simplify, you can see that we have 2 members in any of these lists because any of my surfaces has 2 edges. And actually on any of these points, any of these curves, we have 2 overlap curves. Let me bake this one for a second to see. Bake. I should back it on shade view. Oops, because I bake it several times, we have more than 2. Let's use a bake. And you can see that in any of these curves, we have 2 overlapped actually curves in any of these positions because it is a border of the 2 faces and any of these faces has 1 edge here. So by using this process, it's easy to get rid of those duplicated duplicated curves. If we had edges, I would be able to use remove duplicate lines, but remove duplicate lines doesn't work here. So instead of using this, I can simply use a list item, and because they are duplicated and any of this list has only 2 members, I can remove 1 member of any of my branches. So it is what we wanted to have. And back to Arctic view. So I have these curves and I need only to use this frames process. Select them and make a copy. Oh, yes. Just remove these closed loft because these are only frames. And I'm able to make it smaller, like 0.4. Or 0.5. So use a display. Here, just after this loft. And one here. Yes. And let's back and see what if I didn't want to use 3ds Max for extracting this structure. Here, I would be able to make a copy of this. Actually, cat molecular, change this level to 1. And let's back it shade view. And I want to stop this process for a few seconds. Yes. Let's put a data dam here, and also disable this view. Once again. Yes. This is my object with a less subdivision, and I believe I can use a diagonalize here in Kangaroo to change this mesh topology to have a similar pattern, or I can use it directly here. Yeah, maybe it's better to change this mesh topology. And after having this one, it is really easy to use mesh edges. And maybe I should select all of these edges together. or let's use Weaverbird naked boundaries or Weaverbird's mesh edges. No, actually, it is similar. And somehow I need to get rid of these end meshes, or we can use these ones that not really make a difference. Yes, instead of using 3ds Max, I was able to use this diagonalize. Maybe it is even faster and we didn't need to use that process. And after that, having these curves, I was able to use this mesh pipe, but it is taking to do it again. And if I wanted to have more dense, I was able to use this Weaverbird. Oh. Let's put it here if you later wanted to check. Okay. And what else I should add? Yeah. We are almost at the end of this process, but in this example, I want to show you one more item, which is how we can use these different patterns. Again, we need to export this surface to 3ds Max for making these patterns. I already have this actually surface here, and to save the time, I will show the process on this surface again. Instead of exporting this object again to 3ds Max, let's show you the process here on this surface. All these patterns only happen on the surface. So if I show you this process here, you can see how we can use for such renders, such results. There are actually 2 ways of manipulating this surface. First, I want to use tyFace extrude, a modifier that's going to help me to have a modifier that helped me to have this result. Yes. And I have, let's how this tyFace extrude works. I can back my view to clave mode. And I have an amount that stored all my polygons extrude. And beside these amounts of extrude, I have some other features that I can change. Let's put it like 6. And here I have a scale factor to change these final polygon size. And changing this scale, all these final polygons, these top polygons have similar scales, but by using this variation, I can make differences and some different variations in this extrusion. For example, change this variation to 50. And you can see some of them are smaller, some of them are bigger. Of course, all of these processes are possible in Grasshopper, but here in 3ds Max, thanks to this modifier, it is much easier to manipulate these meshes. Also, we have a variation for extrude amount. All of my extrudes has equal to 6 centimeters extrusion. But if I want to have some of them less extrusion and some of them more extrusion, again, I have a variation here. For example, 25 variation or 18% variations. And they are randomly. It is not like exact variation that I can say to it in which points more variation, in which points less variations, all are randomly, as you can see. And I can use a turbo smooth to make a smoother output. Oops. I have a result like this. Such patterns on this surface. But for this example, actually, I use this face scale like 125, which means you can see that is bigger of the bottom polygons, and they have some intersection to each other. And I use a variation like 20 here, and I didn't use any variation here. Let's make it a bit more. Then we will have something like this, something like this pattern. And next, I want to use another modifier here. Let's imagine I want to have a attractor point for this extrusion. I can use a object for attractor, for example, a sphere. Definitely, you can do attractor concepts in Grasshopper, but having attractors and these something like this typeface extrude together is a bit harder in Grasshopper. So let's look at some possibilities here in 3ds Max. I can add a component modifier called data channel here in my mesh object. And it is a way to computational manipulation. I mean, not a manual selection, but using parameters to select object positions or some area of this object. I can use this add operator. There are different ways of selections, different ways of operators. First, I want to show you this node influence. Add this operator, and this is a selection method. And I want to say initially the thing that I'm going to select. Do I going to select faces, vertices, or edges? For our process, I'm going to use this vertex output and add this operator and put this output as a selection. Or data color. Here I can use, I can use a node for selecting influence, which is this object. And you can see as it gets near to my object, it starts to have some changes on selections. Sorry, selection, yes. And back here, I can change these values to see how much these are not going to influence my object. This is the radius, and we have also some values to manipulate these selection influence, how much it should be sharpened and how much it should be lighter. Yes. For example, I select this part of object, and then I want to use a typeface extrude, X typeface extrude. And you can see that because I use selections, these changes are limited to my selections. And because of these actually data channel selections gradient, those polygons that are near this node are more influenced, and those are that have some distances to this node has a less influence, and easily I can change its position. Yes, and use X turbo smooth to make a smooth result. And back here, put it on like 6, and here should be yes. Yes. It is a way that I can make some attractor points in 3ds Max. But what if I want to have more generic patterns? I mean, right now it is only depends on these sphere positions. Though we can add some other features to this process. I mean, not only typeface extrude, but for example, I can use X, another modifier called push, to make some inflation, for example, here. And also use both of them together. And even I can probably use a symmetry to have something like this, which is interesting. And it is, it is funny, and I want to have this. What I wanted actually, and I should do this sphere. But actually, I wanted to show you one thing more. Let's use another modifier. Let's use another way instead of using this and node influence. And back here, X, use another data channel. Here, I want to use another selection method, which is a distort or distort. I'm not sure how to pronounce distort, I believe. And For output, again, I want to select vertex output. You can see these vertex icon at the front of these operators. It means that they are working according to vertices. So as a output, you again need to output vertices. And here, this sort, instead of asking for an object, it asks us for a map. We can use a map to make selections, and actually we need a gradient between white and black. Those are places that are white means that they are not selected, and those are places that are black that are selected, and those places that are those places are white means they're fully selected, and they get blacker or darker, they are less influenced by our selection. So use a noise here. Use a noise here. And give this noise texture to my map. And here in vertex output, we make sure to this vertex mode is on selection. So you can see that I have selections according to my noise features. Now, the two important noise features for me is a size and this gradient level. We have a height and low. As you can see, we don't have any saturated red or saturated blue. So to have a more emphasis on our selections, I can make this domain smaller. Right now it works between 0 and 1, and I can say that I want to work between 0.3 to 0.7, for example. So the smaller domain we have a saturated color. See, we have a saturated blue and saturated red, thanks to have a smaller domain. And use this push and use this typeface extrude. Those places are more red or saturated red has the most influence, and those places that has this dark blue has the less influence. And use this edit poly and turbo smooth. So how randomly they are changed according to my noise parameters. There are some ways to change these noise textures. The easiest way is changing this size. For example, having a big size of noises. You can see that how these textures are going to change, or I can use these fractal options. And here you can see the texture changes, and here you can see the object changes. And to be honest with you, there are different ways in 3ds Max to make a gradient color between black and white. Maybe it is not really possible for us to cover different ways of making these maps here in maps in general. We have some different ways of making gradient color between white and black. For example, we can use cellular, another way to make such colors. And we have two different cellular options. Let me change this cellular size to see better. And I can use this fractal mode to have more blending between white and black positions. And changing the fractal iterations means that we have more blending between these two. And here we have a spread factor. Maybe it takes some time for you if you want to check all of these possibilities in your own. And if you're interested, I definitely suggest you to explore options that we have. For example, another way of making a gradient pattern is using a smoke or using, I don't know, even, for example, we have a pattern called marble, but we are able to change this color between black and white. Some of them doesn't work here because some of these gradients are not a real black and white, but I believe, for example, this cellular are going to work. Just back here in this sort and change your, oops. Yes, change this one with this one. I can turn these other modifiers off to have a faster process. Back here, and let's see if I can use this cellular. Yeah. Here you can see that my patterns changed. And for this example, yes, the only difference is that I didn't use a typeface extrude. I only use data channel with a noise and a push. This one, I pushed the surfaces in these a random noise to have these forms. If you like, we can do it together. Back, use this noise and make it smaller. Yeah. And then use this push. Playing with these modifiers, we are able to have different results. This one has a workflow like this. And after that, to have a more complexity in this surface, I remember I use another modifier here in Edit Poly. We have a sort of a brush modifier, something more and less like ZBrush brushes, but it is much less abilities and less features. I can use these rotation brushes on my mesh object. And changing my zoom object makes my brushes bigger or smaller. Yes. And also I can use this shift if I want to make some more changes. This is the process. Even I can use again this that tie relax modifier here. Yes. And make a copy of this one. I want to have this pivot at my object center. So come here in hierarchy, use effect pivot only, and use this center to object to make sure that my move selections, my object pivot is at the middle of my object. Back to modifier and yes, I wanted to show you another actually pattern. Here in Desort, I can change this pattern and then use push, use typeface extrude, and use subdivision. Yes. This is our next example. Let me save this file. And save also this Grasshopper file. Before going to have our final example, which is this one, we can have again a 10 minutes break and back to see how we can model this model. Yes. Please let me know if you have any question, and I stop sharing for 10 minutes. Okay, let's continue. And okay, let's see the next example, which is actually this one, and see how we can make this model. How was so far? Was it good or boring? Was it good webinar or really boring webinar? Any ideas? Thanks. So let's continue. And thank you. Thank you, Walter. And let's make a surface. I want to use actually a component that for the next example, first we need to see at I would say an important component called jitter. I'm not sure, are you familiar with a jitter or not, but let's see it together. For those of you who are not familiar, is a good idea to see how jitter works. I have a surface and I use isotrim to divide this surface. For example, 32 parts. Oh, sorry. I used divide domain 2, U direction and V direction. And this is my surface. And give it here. Maybe it is too dense. I can have less surfaces. As a basic knowledge in Grasshopper, we all knows that we have here, we have a list of 32 items, which makes it like 625 faces, 625 these faces. And if I want to divide this list, and if I want to divide this list, I can use actually partition list, and I can extract this list length. Partition list ask me for a size of any of these partitions. I want to have 2 parts, so I can multiply these list items, this list length to actually multiple to 0.5 and give it to size, and this is my list. So as a result, I have 2 separated lists which are almost equal. 300, let's show you using a panel here. Not a panel, but a param viewer. A list with 313 and a list with 312. So if I use explode 3 and give 2 custom preview to them. Let's put one of them is a swatch. And for example, one of them yellow, and one of them blue. We can see that we have a fixed borders here, because if I use a area for all of these points, for all of this list actually, and look at these numbers, this is a 312 and this is a 313, right? This is the border of these 2 lists, 2 groups. But thanks to jitter, I can make some controllable random changes in this border. I need just to put jitter here. And it has a value between 0 to 1. 0 means no shuffling, and 1 means a complete shuffling. Shuffling means that it makes random changes to these list orders. Let's put a number between 1 to 0 here and assign this list here. As I have more shuffling, you can see that in the border, I see more changes. Actually, these changes apply to all the positions, but here, because we have 2 different colors, we can see these changes better. So if I put it like 1, then all these surfaces are random. And if I put 0, there are not any shuffling in these list items. So I want to use this jitter for this object and changing radiuses. Let's look at here. As you can see here, we have here these big radiuses, and here at the top we have smaller radiuses. But at the border, we can see these shufflings. I mean, some of these bigger borders and some of these smaller, some of these bigger radiuses and some of these smaller radiuses are blending together here at the middle of this object. So let's do it together. Just disable this one and put it here. And I have 2 boxes that I already Boolean together. Use Boolean union to have one object of these 2 boxes, and use a brep because they are brep object, and add these boxes to my Grasshopper canvas. As these objects are actually brep, I want to have a list of static points on these brep objects. By static points, I mean I don't want to change these point positions or using particles, but they are going to be fixed at their positions whole the process. So I can use a simple Grasshopper component populate 3D to add a list of points on this object. But actually, because it is not one, this populate 3D works on a rectangular object, and because it is not one rectangle, it has such situation. Maybe it was better if I use 2 separate boxes, but there is no problem. Let me make a big number like 500 points or a bit more, and I want only select those points that are in my object. So I can use point in brep component, point in brep, and this is our brep, this is our points, and we have a list of actually booleans, a list of true and false. So I can use a call pattern to only select those points that are in the object. Yes. And after having these points, I want to sort these points according their z value. Let's look at them right now. I believe they are in a random order. Yes. Here is 2, here is 200, here is 157. So I want to make sure that they are in a rational order and use a deconstruct point. Deconstruct point. And use these z values as my sort list key. Use a sort list component. This is my key and this is my points. And let's make sure that they are in a the smaller number here at the bottom, and the big numbers here at the top. Next, I want to divide these groups to two partition actually. So like the process that I show you here, I can use a list length to see how many points that I have, 216, and then multiply this number to like 0.5. If I wanted to have, for example, a 3 partition, then I would be able to put it on 0.3, for example, and use a partition list. Partition list. This is our list, and this is our list size. And using a param viewer, actually, we have 4 lists. Let me change this. Yes. Yes. And the fact is that if I want to say you why we have a 4 list, as long as I use a 0.3, and the reason is the fact that the answer of this multiplication is a 64.8, which rounded to 65, and even has a 3 list with 65 members. We have still 21 members, and it has to make another list with 21 members. So maybe I can use a bit bigger number. And right now it is 86, and we have 2 groups with 86 number and 1 group with 44 members. However, I want to have 2 groups. Yeah. And then I can use jitter here. And give it a number. This. And I want to have access to these 2 groups separately. Use 3 explode. And look at our groups. This is the first group. You can see the most members of this first group at the bottom, but it has also a few members here at the top. And the reason is that we use this jitter. If I use this jitter on shuffling 1, then we had almost equal members in bottom and equal members at the top. And if I use this jitter value, for example, 0, all the members were in the bottom. But I wanted to have some member at the top and some member at the bottom. I mean, most members at the bottom, but some members at the top. And then we have a similar situation for this second list. Most of members are at the top and has a few members here at the bottom. So I can make a connection between these neighbor points by using proximity, 3D proximity. If I'm not mistaken, yes, proximity 3D. These are my points, and this is a connection between these points. We have a group. That means any of these points should connect to how many of neighbors. And we have a min radius and max radius that show us how much should be the maximum length of any of these edges. I don't want to change these parameters. Maybe I only make this a group to 4 to have less curves. And doing a similar process for this one. So we have two separate connections, but they are blending to each other. Then I want to use a Dendro plugin. Actually, this plugin only works on Windows computers. If you have a Mac computer, sadly, you are not able to this plugin. But because I use this project for promote this webinar, I'm going to show you the process. So having these curves, I can use this curve to volume. And this is my curves. I can use flatten. And for radius, for this one, I want to have a big number like 15. And for this one, I want to have a smaller radius. 18. So I also need to use a settings for these voxel creations, for these volume creations. And this voxel size usually should be smaller numbers, less than 33% of these radiuses. Let's start with 4.5, for example. Yeah. No. You can see we have this thicker structure and we have this thinner structure. And it is really sharp at the corners. I want to make them smoother using a smooth volume component. This is my volume. Leave this one off. And there are different of subdivision type: Gaussian, Laplacian, mean, and median. I want to use this Gaussian. So I should put number 0 here. And iterations means how many times we are going to apply this smooth process on this object. Let's put a big number like 6. This is too much. Let's me put it like 18. Mm, 5. Yes. It is better. And I want to have a similar process for this one. I can make a copy of this. This is a type and this is the iteration. Yes. Make it a bit smaller. And if I want, I can add more points. Yes. And if I want to change this actually point connections, I can change this seed to see other possibilities. For example, with similar numbers of points, I want to change these point positions, point array. I definitely can change this seed. And using a join volumes, I want to join these two volumes together to have only one volume object. So as a result, I have a one dendro volume object of these two. Then I can use actually mesh, volume to mesh. This is the volume, and this is the mesh setting. Because these two objects has similar settings, so it is not really problematic to make one mesh object from these two together. And we have a valid mesh object. Sometimes it makes a problem with invalid meshes, especially when you have two different objects with two different settings. I can also make it a bit smaller. Yes. We have a such result, but it is too organic. I want to have a mirror shape like this. So let's look at our mesh object. Yeah, good. I can use a rebuild mesh to make sure that my mesh is something acceptable. And then I want to make a symmetry here in Grasshopper. For doing symmetry here in Grasshopper, we can use actually mirror cut mesh. And I only need to have a plane at the middle of this object. So there are some better way to make this plane using Grasshopper, but as I get a bit bored, I want to use Rhino here in simple way to make a plane. So I use this a plane, and it asks me for a mirror plane. This is my mirror plane. It asks me for a mesh. This is my mesh. And we have some different connections type, which is one interesting factor that are not able in 3ds Max, that you can change your connection type here in Grasshopper. And yes, I want to put these connection types without connection, split faces, number 3, I believe. For this object, it is better. And sorry. And as you can see, it is a bit different with this example because they are all random. Maybe I can change this radius to have, or make it here. Yes, great. And for making such a small opening in this mesh, definitely if you change these seed factors, you will have some results like this one, or adding more points, for example, you will have a different result. But the process is like what we can see here. For the next part, let's look at this mesh a bit better. I can use a swatch, color swatch. And look at these mesh polygons. It is not like quad meshes that are all polygons are similar in size. We have different polygons, different faces with different area. And for this pattern, I only want to have opening on these bigger actually faces. So for doing so, I can use mesh explode, just preview this one off because we are going to have a lot of smaller meshes, and visualizing this process a bit problematic for Grasshopper. So it is a good idea to make sure that off this preview and then use this mesh object here. And let's see if I can use a join mesh here, and then give it. Yes, instead of having one mesh here after join mesh, I had one mesh with 217,000 mesh faces. Instead of having such mesh, I have 217 separate meshes with only one face each of them. I mean, any of these faces become a separate mesh. So I can use mesh area. Mesh area, preview this one off, and just save this file. And save this. Yes. And I can remap these areas in a domain between 0 and 1, because I wanted only select bigger faces. And use a call pattern, use larger. These are my numbers, and for example, 0.45. I can use this one as a pattern, and these faces, just preview this one off. To select a list of faces, and then use a join mesh to again have one mesh of all these faces. So let's look at our result. Yeah, there are, I want to have more meshes. By changing this number slider, I can select more and more meshes, because I can say meshes in which areas, which size I'm going to select. If I cannot mesh explorer, can we do it with mesh faces? Yes, I believe so. Let's use mesh faces. Is it a component mesh faces? Sure. So decones mesh, I'm not familiar with this component. Decones. Deconstruct mesh. Oh, no. Deconstruct mesh does not work like this. Actually, deconstruct meshes, no, it doesn't work like mesh exploit. I believe mesh exploit is a component that you can find in Food for Rhino, but let's see deconstruct mesh. Deconstruct mesh, and let's see. No, I don't think so. It's better to use mesh. And then after I extract these bigger faces, I can use a Mesh Plus plugin to make a pattern on these meshes. I want to use a simple patterns, a simple frame. Let's use this one. And make a frame. Oh, call faces components, yes. Yes, great. And I can also invert this selection. And then use a join mesh. To join all of these together. And let's get the result. I need to rebuild this mesh again. Or I can use a Weaverbird. That one can work. Here we have such opening. And I believe there is a problem by using this Weaverbird. See if I use this one. Yes, it is better. Once I use cat molecular, because these faces are not weld, we had some opening problems here at the borders, because this subdivision works like separately for any faces. And I'm not sure that I'm able to make a weld between these vertices or not. Next, 0, 3. See. It makes some problem. So initially, we don't not need to make a word between them. Yes. Here, a process for this example. And for the final stage of our webinar, I'm going to show you some renderings. Let me save this example and back here. And for rendering, I want to render this example, the first example. Actually, let's see where yes, let's do a rendering for this. This Max has a really powerful abilities for making interesting renders, and most people use 3ds Max for its rendering abilities. So we have a lot of tools and modifiers that we can use for having a good render. But here in this example, I want just show you a quick ways to make conceptual renders as things that I personally use. I use mostly conceptual renderings and not those realistic renderings. And let's see how we can make a quick render with these objects. First of all, we need to come here in rendering and this render setup toolbar tab, opening this render setup tabs, and here in a comment, we have assigned render. I'm going to use a Corona render, and if you are able to install a Corona render, you can see that here in choose render engine, you have a Corona options, and you can run your Corona option. For example, I have also V2.0 option here, and because my Corona is already run, I don't have this Corona in my list. And after choosing this Corona, you will have also these tabs. First, I started with giving a simple materials to this object and to the ground. Basically, we have some maps and some materials. Maps mean different textures that we can use, and materials means that different material slot that we can use. We call these objects a material slot. And if I open this Corona toolbar, you can see that we have different options. I use Corona version 8, but because I'm get accustomed with these previous previous material options, I use a Corona legacy material, which is easy to use and give us a good result. So come here in materials and use these Corona legacy material. And once you assign this material to the object, you can see that there is a sign that shows us this material belongs to an object in your scene. And obviously, we can change the color or change the reflection and the reflection. But for having a better process, I usually like to see interactive renders as long as I'm playing with these textures. So I change my layout to 2 views. One of these views going to be my render process. And another view going to be my works. Because I want to render from this view, I select this view and you can see this yellow border around this view, which means this view selected. And after selecting this view, I can come here and use this lock icon. Like my viewport, that means just render this viewport. And after that, I can come here and add some lights. Here in lights, modify lights options, I have a corona lights. And I want to add a rectangle light. Press E for rotation and W for move. To make sure that my light has a target, I can come here in modifier and turn off this target, then right click on my light. Once my light selected, I can use this select light target to move this light target. And once my light target selected, I can right click and use select light to change my light position. And start with interactive render. At some initial views of my rendering, and I can start to change these light positions. And for example, change my view position. Yes, there is one point. My viewport is different with my render frame. To see my render frame at the viewport, I can press Shift and F, which means a save frame. Shift and F key to see my render frame. And right now I can change this position. So as you can see, this before doing this render, it gets a bit blur to show the final render to us. I can use, if you have a good system, an acceptable system for rendering process, you can deselect this fast preview denoising during render to avoid those blur views before doing the render. If you have this one, anytime you change your position, it starts to make a blur views and then making your render in interactive mode. But without this key, it is a better actually process to see your interactive render. And let's make a copy of my light. Press Shift and move this object to make a copy. Any object in 3ds Max is possible to make a copy in this way. For example, I have a box and I want to make a copy. I only need to press Shift and move to make a copy of this object. And I am able to play with these light positions. And we have some post-process ability here in tone mapping. Usually having more contrast makes it more mysterious and more interesting, having a sharpened contrast between light and between bright and dark actually spaces. I usually use this contrast, and also I can use another feature here by using this plus sign, which called LUT, some color effects that we can see in our object, in our render. And make it less opacity. We have also this exposure. Here is too bright. And by changing this exposure, I believe I'm able to modify this a bit. Or we have another option to control these exposures here. Actually is highlight a compression, I believe. Yes. By changing this highlight compression, you can also modify these two bright positions. And we have also this filmic mapping. Another ways to change highlight compression and make these shadows darker or richer. So that's a really quick way to make conceptual renders, but I want to also have some details on my object surfaces. I can come here and for diffuse color, is it my object? Let's make sure. No, it is the frames. I can change this name to lattice. And this is for my object. So, yes, I want to use another Corona feature here, which is Corona wire. I like to see mesh wires during renders. So just I need to use this Corona wire for diffuse and make it a bit smaller. Yes. And I can also change this wire color and make it reflective. We have a reflection level and personal IOR to manipulate and glossiness to manipulate these reflection on these steel wires. And I'm able to make a bloom and a glare on these light reflections by using this modifier. So I'm also able to playing with these light colors, for light colors and power in these post-processing renders. We have a light mix option to manipulate my lights without doing this render again. Just I need to stop the render back here in render setup. Yes, render setup. We can bring render setup from here. Rendering, render setup. And here in scenes, we have a setup light mix to generate these lights in post-processing renders. And again, start interactives. So I can turn off my light here, or I can change its power without doing a render again, or I can change its color. And let's do something else together on this object for having a bit better render. As I like these borders, I want to have more emphasis at these mesh borders. Just add another edit poly here and select these borders. Yes. Use a create shapes to make shapes of these borders. And select these shapes. Here in shapes modifier, I have a rendering option. I can use enable in render and enable in viewport to see some, you can see these pipes here at these borders. And what I like to do is giving a light material to these pipes. Corona light material is another features of Corona materials, and I can assign these materials to these mesh pipes. And just maybe I need to have a smaller thickness. And let's look at the render. I need to have more light density. That's too much. And I can change its color because we added this new light after using a light mix. You know, I first use this setup light mix. I set up my lights and then added these pipe lights. So it comes here in rest unassigned lights because we added this one after doing set up my lights. I can turn off it here because it has a yellow. It takes a few seconds to turn off or turn on and change its color. Maybe something like this is interesting, maybe. And we need to make these thickness smaller again, like 2. And with having these lights, I can decrease this intensity. Yes. I want to have some shines, some glare for my lights. So I change this size values to have a better glare. And make it smaller, its thickness. No. And I want to have some reflection on the ground. So select this ground material, add it a reflection. And I want to make this reflection a bit blur actually. So I can use this glossiness to have a blur reflection. Because I want to focus only in this part, I can use this region render to see only this part, to make render only on this part. Yes. So and there are some other post-process renderings tools that you can check. And once you are happy with the render, you can come here in render setups in the comment toolbar, and we have output size to change my render ratio. Actually, it is better to fix your render ratio and then make this your camera fixed. And for example, I want to have something like this. And once you have the appropriate image aspect, you can use this lock to make sure that it is locked, and then you can make this number bigger to have high quality render. For example, I want to use 100 and 1500, and it's automatically apply to this weight to lock this image aspect, to maintain this image aspect. And finally, we can press the render. One other point, for the final render, it is a good idea to use a denoising. For interactive renders, I don't like to use denoising, but for the final render here in scene, we have this denoising ability, and I would like to use a GPU AI for denoising, NVIDIA GPU AI denoising. And also, if you don't introduce any limitations for render passes, you have to stop it manually. But you can introduced limitations here in render pass limits. For example, I want to have 15 or 18 passes. And then once I just set this one. And you can see that we have 18 render passes and it start to make renders. And whenever it finished all of these passes, it's going to stop our render. And yes, I can stop this one. This was the last point that I wanted to mention, and let me know if you have any question or we can finish our webinar. Any question, any suggestion? Thank you for your attention.
Hi, Amir.
Hi, how are you?
Are you done with the tutorials?
Yes, it is finished.
Cool. Thank you so much.
Thank you.
We always leave time for questions, more in depth.
Yes.
If anyone has any questions, please feel free to ask, or if you want to see something or you have something else that you missed, please let us know. If anyone has a question. And as always, webinar will be sent by email. When it's done, you'll get an automatic email with the link to review. Okay, let's see. And anyways, optimize performance, especially when there are lots of elements we're using multiplied or large number of voxels.
I'm not sure what you mean by optimize the performance. If you means to have a faster calculate, the only way that I know is a turn off the preview, and maybe it sometimes helps to have a faster process of calculating, but I'm not sure if any ways to optimize the performance with a lot of elements. Do you have any idea, Michael?
Well, let's see. Can you look at the mesh explode component? What's the time on that? 1.2 seconds.
Yes, it's too time taking.
That's one.
Actually,
you can do. Okay. Maybe that's one we can do.
you mean use call face?
Yeah, but you have to get the
Yes, pattern.
yeah. But you need to get the the area. I think you can get it.
Yes. Yes, sure. You can reach me either using Instagram or you can send me email. Let me put my email address here. My email address is Amir Fakhrghasemi @yahoo.com. We'll be happy to answer your questions. And regarding the fabrication, actually, I don't have any ideas about fabrications methods, so I'm not a good person to answer this question. And
You can do, so if you do base boundaries,
with what component?
base boundaries,
Face.
face, F-A,
Face
F-A-C.
boundary.
Yeah. Base
Face.
boundaries. Yeah.
Yes.
And plug the mesh join into that. And then do polygon center.
You mean extract area?
No, don't do area, do polygon center. It has a
Polygon.
has a footer. Yeah, polygon center. We'll move the E from polygon. Yeah.
Yes, yes.
Use that. I don't know if it'll be faster. No, it's slower.
However, this one was enough fast, I believe. Actually, this process is not a parametric base. I mean, it is really hard to consider that you want to do this process with changing different items. Maybe you can use a data dam here, and once you are happy with the mesh result, then you run rest the process for extracting. I mean for extracting this.
Grasshopper is just, in general, like, it's not. It can be slow with these kind of heavy meshes, but it's still faster than doing it manually. So
maybe I can put a data dam here, and if I want to change any of these parameters, I can see the different results, and once I'm happy with them, run this process to extract these frames.
Yeah.
Thank you. And let's see if there is any.
Grasshopper,
so
I mean, you just have to have the right hardware right now.
Yeah.
Okay, well, we can end it here. Thank you so much.
Thank you, and
thank you everyone who joined. And
yes.
Keep in mind the webinar tomorrow for anyone that is interested in that one as well. Today is the last day to register for it. And yeah, until next time. See you, Amir.